let's derive an equation for energy stored in a capacitor. Energy means what? It is the capacity to do work. So in order to find the energy stored in a capacitor, we have to find how much work we have to do to transfer the charges on the capacitor. Now consider a parallel plate capacitor having two parallel plates. This is a parallel plate capacitor having two plates, 1 and 2. Let C be the capacitance of this capacitor. This capacitor initially is uncharged, that is the charge on the capacitor initially is 0. Now connect a battery across this capacitor, then the charges will store on the two plates. In this case of charging, consider an intermediate situation. In this intermediate situation, the amount of charge stored on the two plates will be plus Q on the plate 1 and minus Q on plate 2. In this intermediate situation, during charging the capacitor, let the plate 1 accumulates plus Q charge and plate 2 accumulates minus Q charge. As the charges plus and minus Q are accumulated, there exists an electric field and the direction of the electric field is positive charge to negative charge. Then the potential difference exists across this capacitor and let us take that potential difference as V dash. The potential difference across the capacitor during this intermediate situation. And this potential difference can be given by the equation V dash is equal to Q by C. How we obtain this one? We know the basic relation between capacitance, potential and charge, that is C is equal to Q by V. If we rearrange this equation, equation now V goskara change madre, V dash will become Q by C. Let us now move a small amount of charge plus dq from the plate 2 to 1 against this electric field. So in order to move this charge from plate 2 to 1 against this field, we have to do some work. So let us take that work done. To move charge from plate 2 to plate 1 is given by dW is equal to V dash into dQ. We know the expression for work done in terms of potential difference, that is W is equal to potential difference into the charge. Here the potential difference is V dash and we are moving the charge dq. So the work done becomes dW is equal to V dash into dq. Substitute for V dash here from this equation. So it becomes Q by C dQ. Our intention is to completely charge the capacitor from initially 0 to, after charging the capacitor, the plate should have the charge capital Q. In order to do this, we have to do large amount of work. So the total amount of work done to charge the capacitor from Q is equal to 0 to Q is equal to Q. Our intention is to charge the capacitor such that it should acquire the charge capital Q. Initially it is uncharged, so 0. From 0 to acquire the charge capital Q. What is the total amount of work done? That we will get by integrating this equation. So the total work done W will be equal to integral dW, and the limit is from 0 to Q. Substitute for dW here. So it will be equal to 0 to Q by C dQ. Here C is the constant. Capacitance of a capacitor is a constant. I am taking this C outside this integral equation. So it becomes W is equal to 1 by C integral 0 to Q dQ. We know the integrational formula, that is integral of x to the power of n dx will be equal to x to the power of n plus 1 divided by n plus 1. Applying this integral formula here in the place of x we are having q, and in the place of dx dq, and the power here in the place of n we are having 1. So applying this integral formula we will get here 1 by c. So q power is 1, so n plus 1 becomes 1 plus 1 2, q square divided by 2, and the limit is 0 to q. Apply the upper limit and then lower limit. So the work done, W will become 1 by c. Applying the upper limit, it becomes q square divided by 2 minus lower limit 0 by 2. So 0 by 2 is 0. So we will finally got 1 by c q square divided by 2. That is, the work done is equal to of q square divided by c. This amount of work done will store as an energy in the capacitor. So the potential energy stored in the capacitor is given by U is equal to of q square by c. This is the expression for energy stored in a capacitor. We can also write this expression in another two forms by substituting back for q and c. Substitute for q. So from this equation, C is equal to Q by V. If you substitute for Q, it becomes CV. So or here Q So here it is Q is CV, then it becomes C square V square divided by C. Here 1 C and the C square gets cancelled. So we got U is equal to half CV square. This is another form of energy equation in terms of C and V. Again, here we will get the energy equation in terms of Q and C. Here in terms of C and V. The other possible way of writing this equation is in terms of Q and V. For that, here what we have to do, substitute for C as Q by V. Or Q by V into V square. So here 1V and power will get cancelled. You got U is equal to half Q into V. These are the three forms of energy equation, energy stored in a capacitor. These forms of equation are useful while solving the numerical problems regarding energy stored in a capacitor. Let us solve some numerical problems on electric potential. So, you want the problems to solve ಇದಕ್ಕೆ ಬೇಕಾಗಿರುವಂತ ಫಾರ್ಮುಲಾಸ್ ಗಳು ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್ ಬರುತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಫಾರ್ಮುಲಾಸ್ ಯಾವ್ಯಾವ ಅಂತ ನೋಡೋಣ. ಸೊ ಮೊದಲನೇದಾಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ V is equal to 1/4 pi epsilon naught Q by R. The electric potential at a point due to a charge Q is given by 1/4 pi epsilon naught Q divided by R. If there are multiple charges are there, then the net electric potential at a point due to multiple charges again formed as V is equal to V1 plus V2 plus V3 etc. ಇದೇ ರೀತಿ ಇನ್ನೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಫಾರ್ಮುಲಾ ಇದರಲ್ಲಿ ಬರುವಂತದ್ದು ಯಾವುದಂದ್ರೆ the work done in order to move a charge from infinity to a point. So that work done will be equal to the potential difference into the charge. Now read the problem. Two charges 3 into 10 power minus 8 coulomb and minus 2 into 10 power minus 8 coulomb are located 15 cm apart. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So, ಅದಕ್ಕೆ ಎರಡು ಚಾರ್ಜ್ ಗಳನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ ಎರಡು ಚಾರ್ಜ್ ಗಳು 15 ಸೆಂಟಿಮೀಟರ್ ದೂರ ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ಎರಡು ಚಾರ್ಜ್ ಗಳನ್ನು ನೋಡೋಣ. Q1 Q2 Q1 Q2 ಅಂತ ಎರಡು ಚಾರ್ಜ್ ಗಳನ್ನು ತೆಗೆದುಕೊಳ್ಳೋಣ. ಅವೆರಡು ಚಾರ್ಜ್ಗಳು ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಅಪಾರ್ಟ್ ಆಗಿದೆ ಅಂದ್ರೆ 15 ಸೆಂಟಿಮೀಟರ್. And the distance between the two charges is 15 centimeter. Now we have to consider or take points at which the electric potential should be 0, and that point should be along the line joining the two charges. Now ಒಂದು ಪಾಯಿಂಟ್ ತಗೋಬೇಕು. ಆ ಪಾಯಿಂಟ್ ಎಲ್ಲಿರಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ಈ ಚಾರ್ಜಸ್ ಗಳನ್ನ ಜಾಯಿನ್ ಮಾಡಿರೋ ಲೈನ್ ಅಲ್ಲಿ ಇರಬೇಕು. ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ 0 ಆಗಬೇಕು. ಹಾಗಾದ್ರೆ ಆ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ ಅಂತ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕು. ಸೊ ಇದರಲ್ಲಿ ಎರಡು ಕೇಸ್ ಬರುತ್ತೆ. ಸೊ ಮೊದಲನೇ ಕೇಸ್ ಅಲ್ಲಿ ನಾನು ಪಾಯಿಂಟ್ಸ್ ನ ಬಿಟ್ವೀನ್ ದ ಚಾರ್ಜಸ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ನಾವು ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಅ ಪಾಯಿಂಟ್ P which is at a distance x1 from the charge q1. ಸೊ ಒಂದು ಪಾಯಿಂಟ್ P ನ ತಗೊಂಡಿದ್ದೀನಿ. ಅದು q1 ಇಂದ x1 ಅನ್ನೋಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಈ ಪಾಯಿಂಟ್ P ನಲ್ಲಿ ನೆಟ್ ಪೊಟೆನ್ಷಿಯಲ್ 0 ಆಗಿದೆ. ಹಾಗಾದ್ರೆ x1 ಅನ್ನೋದು ಎಷ್ಟು ದೂರ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವು ಕಂಡುಹಿಡಿಯಬೇಕು. We have to find x1 where the net potential at the point P is 0. So now the net potential potential V will be equal to V1 plus V2. So ಇಲ್ಲಿ ಎರಡು ಚಾರ್ಜ್ Q1 Q2 ಇರೋದ್ರಿಂದ net potential, the potential at the point P due to Q1 plus the potential at the point P due to Q2. ಇದು net potential ಆಗುತ್ತೆ. ಅದು ಏನಾಗಿರಬೇಕು? Which will be equal to 0. Now this implies, so apply the formula for V1 and V2 from here. So V1 becomes 1 by 4 pi epsilon naught Q1 divided by the distance is x1 plus 1 by 4 pi epsilon naught Q2. So what is the distance for Q2 from the point P? From Q1 to Q2 distance is 15 cm. From Q1 to P it is x1. If you subtract 15 minus x1, you will get P to Q2 distance. That is, this distance will be 15 minus x1. So Q2 will become 15 minus x1, which will be equal to 0. Now substitute for Q1 and Q2. So Q1 is 3 into 10 power minus 8 molar, 1 by 4 pi epsilon naught, 3 into 10 power minus 8 divided by x1. Here for Q2 we have to substitute minus 2 into 10 power minus 8. Here minus is there, so plus into minus minus. So I am right here minus 1 by 4 pi epsilon naught 2 into 10 power minus 8 divided by 15 minus x1, which is equal to 0. Now take this minus term to right side, so it becomes plus 1 by 4 pi epsilon naught 3 into 10 power minus 8 divided by x1. If we take this term to right side, equals 1 by 4 pi epsilon naught 2 into 10 power minus 8 divided by 15 minus x1. The common terms, equal sign na akade matte ikade iruವಂತ common terms ಗಳು cancel ಆಗ್ತವೆ. So here 1 by 4 pi epsilon naught, ಇದು 1 by 4 pi epsilon naught. Then 10 power minus 8, 10 power minus 8. So the remaining thing is 3 divided by x1 equals to 2 divided by 15 minus x1. Now cross multiply. So we will get 3 into 15 minus x1 is equal to 2 into x1. So multiply from 3 to the terms 15 and x1. So 3 into 15 is 45 minus 3 into x1, 3x1 is equal to 2x1. Take this minus 3x1 term to right side. 45 is equal to 2x1 plus 3x1. 45 is equal to 2x1 plus 3x1 is 5x1. We have to find x1. So x1 will be equal to 45 divided by 5. So x1 is equal to 9 centimeter. If you write it in meter, so it will become 0.09 meter. That means at a distance of 0.09 meter, the point P from Q1, the electric potential is 0. This is first case. Now, for the second case, I am considering the point away from these two charges. That is, at a distance x2 from the charge Q. So, ಈಗ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಪಾಯಿಂಟ್ P ನ ಈ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜ್ ಇಂದ ಹೊರಗಡೆ ಬಟ್ ಅಲಾಂಗ್ ದ ಲೈನ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಈ ಪಾಯಿಂಟ್ P ಅನ್ನೋದು ಎಷ್ಟು ದೂರದಲ್ಲಿದೆ ಅಂದ್ರೆ Q2 ರಿಂದ H2 ಅನ್ನೋ ಡಿಸ್ಟೆನ್ಸ್ ಇದೆ. ಹಾಗಾಗಿ ಮಾಡಿದ್ರೆ ಈ x2 ಅನ್ನೋಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು, ಜೊತೆಗೆ ಈ ಪಾಯಿಂಟ್ P ನಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ 0 ಆಗಿದೆ. ಸೊ ಈಗ again the net potential at P, which is at a distance of x2 from q2 is 0. So we are considering the point P along the line joining the two charges at a distance x2 from q2, and at this point the electric potential is 0. Again same thing, V is equal to V1 plus V2 will be equals to 0. So substitute for V1 and V2. V1 is 1 by 4 by epsilon naught Q1 divided by, what is the distance of charge Q1 from the point P? So here from Q1 to Q2 the distance is 15 centimeter. From Q2 to P it is x2. So the total distance from Q1 to P is 15 plus x2. So 15 plus x2 plus, substitute for P2, 1 by 4 pi epsilon naught Q2 divided by the charge Q2 from the point P, the distance is x2, which will be equal to 0. Substitute for Q1 and Q2, the values of Q1 and Q2, so it becomes Q1 is e to 10 power minus 8 divided by 15 plus x2. Here Q2 is minus 2 into 10 power minus 8, so plus into minus minus, so minus 1 by 4 pi epsilon naught 2 into 10 power minus 8 divided by x2 equals to 0. Second simplification, take this term to right side. Divided by x2. Again, cancel the common terms. 10 power minus 8, 10 power minus 8. So the remaining thing is here 3 divided by 15 plus x2 equals to 2 divided by x2. Cross multiply, 3 into x2 is equal to 2 to 15 plus x2. So 3x2 will be equal to 15 into 2, 30 plus 2 into x2, 2x2. Take this 2x2 terms to the left hand side, so it becomes 3x2 minus 2x2 is equal to 30. So 3x2 minus 2x2, you will get x2, which is equal to 30 centimeter. Or we can also write this as 0.0.3 centimeters. So that means the point P is at a distance of 0.3 meter from Q2. So at this point the electric potential will be 0. So these type of problems, they are regularly asked in the annual examinations. NC. N ಅಂದರೆ nano, 10 power minus 9. 10 nanocoulomb and minus 5 nanocoulomb are placed at corners A, B, C respectively. Calculate the work done in transferring a charge of 5 UC. U ಅಂದರೆ micro, 10 power minus 6 coulomb from D to the point of intersection of diagonals. So ಅದರಲ್ಲಿ ನಾವು ಫಸ್ಟ್ ಏನು ತಗೋಬೇಕು, ABCD ಅನ್ನೋ ಒಂದು ಸ್ಕ್ವೇರ್ ನ ತಗೋಬೇಕು. ಅದರ ಸೈಡ್ ಎಷ್ಟಿರಬೇಕು, 2 ಮೀಟರ್. ಸೊ ನಾನು ಆಲ್ರೆಡಿ ABCD ಅನ್ನೋ ಒಂದು ಸ್ಕ್ವೇರ್ ನ ತಗೊಂಡಿದ್ದೀನಿ. ಸೊ ಕಾಲ್ ದ ಸ್ಕ್ವೇರ್ ಆಸ್ ABCD. ಸೊ ಅದರ ಸೈಡ್ ನ ಲೆಂತ್ ಎಷ್ಟಿದೆ, 2 ಮೀಟರ್. ಸೊ ದಿಸ್ ಇಸ್ 2 ಮೀಟರ್. ಸ್ಕ್ವೇರ್ ಅಲ್ಲಿ ಎಲ್ಲ ಸೈಡ್ಸ್ ಈಕ್ವಲ್ ಇರೋದ್ರಿಂದ 2 ಮೀಟರ್. ನೆಕ್ಸ್ಟ್ these charges are placed at the corners A, B, C, D ನಲ್ಲಿ ಚಾರ್ಜಸ್ ಏನೇನಿದೆ, A ಅನ್ನೋ ಪ್ಲೇಸ್ ನಲ್ಲಿ 5 nanocoulomb, B ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 10 nanocoulomb, C ನಲ್ಲಿ -5 nanocoulomb ಅನ್ನುವಷ್ಟು ಚಾರ್ಜ್ ನ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದಾರೆ. Next, what you want to calculate? Calculate the work done in transferring a charge of 5 microcoulomb from D to the point of intersection of diagonals. So, ಎರಡು diagonal join ಆಗುವಂತ point of intersection ಗೆ D ಅನ್ನೋ ಪಾಯಿಂಟ್ ಇಂದ ಒಂದು ಚಾರ್ಜ್ 5 ಮೈಕ್ರೋಕೂಲಂಬ್ ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗಿದೆ. ಸೊ ಈಗ ಡಯಾಗ್ರಾಮ್ ಅನ್ನು ಡ್ರಾ ಮಾಡೋಣ. AC BD, the point of intersection of the diagonal called as O. Now, in order to move the charge from D to O, 5 microcoulomb, what should be the work done? Work done ಎಷ್ಟಾಗಬೇಕು, D ಇಂದ O ಗೆ ಚಾರ್ಜ್ Q ನ ಮೂವ್ ಮಾಡಬೇಕು. ನಮಗೆ work done equation ಅನ್ನು ಆಲ್ರೆಡಿ ಬಂದಿದೆ. That is work done is equal to potential difference into the charge. So ಇಲ್ಲಿ potential difference ಯಾವ ಎರಡು ಕಡೆ potential difference ತಗೋಬೇಕು, the potential difference at the point D and O. That is the work done will be equal to VD difference VO into the charge Q1. ಸೊ ಹಾಗಾದ್ರೆ ನಾವು VD ಎಷ್ಟು ಮತ್ತು VO ಎಷ್ಟು ಅಂತ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಸೊ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂದಾಗ ಫಾರ್ಮುಲಾ 1/4πε0 the charge divided by the distance to the point. ಈಗ ಫಸ್ಟ್ let us calculate VD. So the formula for VD is equal to the potential at the point D will be equal to the potential due to the charge at A, charge at B and charge at C. That is VD is equal to VA plus VB plus VC. So formula ದಲ್ಲಿ ನಮಗೆ ಏನು ಬೇಕು, R ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟು ಅಂತ ಬೇಕು. ಸೊ D ಅನ್ನೋ ಪಾಯಿಂಟ್ ಇಂದ A ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ 2 ಮೀಟರ್ ಗೊತ್ತು, C ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ 2 ಮೀಟರ್. ಅಂಡ್ ವಾಟ್ ಅಬೌಟ್ B? D ಇಂದ B ಗೆ ಎಷ್ಟು ದೂರ ಇದೆ, ಆ ಡಿಸ್ಟೆನ್ಸ್ ದಟ್ ಇಸ್ DB ಎಷ್ಟು ಅನ್ನೋದನ್ನ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ಅದಕ್ಕೆ ನಮಗೆ ಒಂದು ಸ್ಕ್ವೇರ್ ನಲ್ಲಿ ನಾವು ಡಯಾಗನಲ್ ನ ಡ್ರಾ ಮಾಡಿದಾಗ ಅದಕ್ಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ಇದೆ. ಏನಪ್ಪಾ ಅಂದ್ರೆ ದ ಡಯಾಗನಲ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ ಟು √2 ಟೈಮ್ಸ್ ದ ಸೈಡ್. ಇದು ಹೇಗೆ ಬರುತ್ತೆ ಅಂದ್ರೆ ನಾವು ಟ್ರಯಾಂಗಲ್ BDC ತಗೊಂಡು ಇದು ರೈಟ್ ಆಂಗಲ್ ಟ್ರಯಾಂಗಲ್ ಆಗಿ ಪೈಥಾಗರಸ್ ಥಿಯರಂ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಗೊತ್ತಾಗೋದೇನೆಂದ್ರೆ ಡಯಾಗನಲ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಈಕ್ವಲ್ ಟು √2 ಇಂಟು ಸೈಡ್. ಸೊ ಇಲ್ಲಿ √2 ಆಗಿ ಇಟ್ಕೊಳ್ಳೋಣ. ಸೈಡ್ ಎಷ್ಟಿದೆ, ಸ್ಕ್ವೇರ್ ಸೈಡ್, ಸೊ ಇಟ್ ಇಸ್ 2 ಮೀಟರ್. ಸೊ √2 ಇಂಟು 2 that is equal to 2 √2 meter. So that means the 1 by 4 pi epsilon naught. The charge at A is 5 nanocoulomb. I will write nano as cm divided by the distance is 2 plus for baby 1 by 4 pi epsilon naught. The charge at B is 10 divided by the distance from for the point B from D is how much? That is 2 root 2. So 2 root 2, coulomb is not necessary. Then plus BC 1 by 4 pi epsilon naught. The charge at the point C is minus 5 nano divided by the distance is 2 meter. So if you see the first term 1 by 4 pi epsilon naught 5 nano divided by 2, and the last term is here plus is there, here minus is there, plus into minus minus, the same thing will come 1 by 4 pi epsilon naught 5 nano divided by 2. So these two terms gets cancelled. It is plus and it is minus. The remaining thing is 1 by 4 pi epsilon naught 10 into nano is 10 power minus 9 divided by 2 root 2. So 1 by 4 pi epsilon naught value we already know, it is 9 into 10 power 9 into 10 into 10 power minus 9 divided by 2 root 2. So here 10 power plus 9, 10 power minus 9. So it will be equal to 10 power 0, that is 1. 9 into 10 is 90 divided by 2 root 2. So here if it cancels, 2 ones are 45 times. 45 divided by root 2 value is 1.414. So if you divide 45 divided by 1.41, we get 31.82, and the unit for the potential is volt. Next, we have to find what is VO. So in order to find VO, we have to know what is the distance, that is DO, OB, OA and OC. So VO ನಲ್ಲಿ ನಾವು ಪೊಟೆನ್ಷಿಯಲ್ ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂದ್ರೆ R ಅನ್ನೋ ಡಿಸ್ಟೆನ್ಸ್ ಈ ಚಾರ್ಜಸ್ ಗಳಿಂದ ಎಷ್ಟು ದೂರದಲ್ಲಿ ಇದೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಅಂದ್ರೆ ನಮಗೆ ಬೇಕಾಗಿರೋದೇನು DO, AO, BO, CO ಎಷ್ಟು ಅಂತ ಬೇಕು. ಸೊ ಒಂದು ಸ್ಕ್ವೇರ್ ನ ತಗೊಂಡ್ರೆ ಆ ಡಯಾಗನಲ್ ನ ಇಂಟರ್ಸೆಕ್ಷನ್ ಪಾಯಿಂಟ್ ಆ ಡಯಾಗನಲ್ ನ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಸೆಂಟರ್ ಅಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ if you take the diagonal DB ಅನ್ನೋ diagonal ತಗೊಂಡ್ರೆ OA, OB equal to OD, which will be equal to DB divided by 2. So BO ಎಷ್ಟಿರುತ್ತೋ OB ನು ಅಷ್ಟೇ ಇರುತ್ತೆ, OC ಎಷ್ಟಿದೆಯೋ OA ಕೂಡ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ಇಂಟರ್ಸೆಕ್ಷನ್ ಪಾಯಿಂಟ್ ಇಂದ ಕಾರ್ನರ್ಸ್ ಗೆ ಇರುವಂತ ಡಿಸ್ಟೆನ್ಸ್ ಸ್ಕ್ವೇರ್ ನಲ್ಲಿ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್, ದಟ್ ವಿಲ್ ಬಿ ಈಕ್ವಲ್ ಟು half of its the diagonal length. So db already ನಮಗೆ ಗೊತ್ತು 2 root 2 meter. So 2 root 2 divided by 2. So this will be equal to root 2 meter. That means OA, OB, OC, OD will be equal to root 2 meter. So now we have to find what is VO. Now let's find what is VO. That is the potential at the point O due to the charges at A, B, C. Now take VO, which is equal to VA plus VB plus VC, which is equal to 1 by 4 by epsilon naught. So the charge at A is 5 divided by the distance of the charge at A from O. So we already find out it as OA OC equals to root 2 meter. Therefore, it becomes root 2 plus 1 by 4 pi epsilon naught. The charge at B, it is 10 nano divided by the distance of the point B from O is again root 2 plus the charge at C is minus 5. So 1 by 4 pi epsilon naught minus 5 divided by root 2. Again, if you see the first term and the last term, plus into minus, minus. So these two terms get cancelled. The remaining thing is V0 is equal to 1 by epsilon naught 10 into 10 power minus 9. 10 into 9 is 10 power minus 9 divided by root 2. So the value of 1 by 4 pi epsilon naught, we know it is 9 into 10 power 9 into 10 into this two cancel. 10 power plus 9, 10 power minus 9 will become 10 power 0. 10 power 0 is 1. So 9 into 10 is 90. So root 2 value is 63.64. 90 divided by 1.414. We will get 63.64 volts. Now find out what is work done. So we already find out VD. VD will be equal to 31.82 volts. So the work done in order to move the charge 5 microcoulomb from D to O is VD minus which is greater, VO is greater, no? So you have to take VO minus VD into Q naught. So it will be equal to, substitute the values of VO and V0. VO is 63.64 minus 31.82 into Q naught is 5 microcoulomb. That is 5 into micro is 10 power minus 6. So which will be equal to, if you subtract this from 63 minus 64, 31 minus 82, you will get 31.82 into 5 into 10 power minus 6. Multiply 5 2s are 10. 5s are 41. 9 is 50. So you will get the work done equal to 159.1 into 10 power minus 6 joules. So this is the work done. So you may see this type of problems in first chapter where you have to find the electric field. Electric field ಕಂಡುಹಿಡಿಯೋದ್ರಲ್ಲಿ ಕೂಡ ಇದೇ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ಕೇಳಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ವೆಕ್ಟರ್ ಆಗಿರೋದ್ರಿಂದ ನಾವು ಡೈರೆಕ್ಷನ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಪೊಟೆನ್ಷಿಯಲ್ ಸ್ಕೇಲರ್ ಆಗಿರೋದ್ರಿಂದ ನಾವು ಈಸಿಯಾಗಿ ಅಡಿಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇದೇ ರೀತಿ ನಿಮಗೆ ಟ್ರಯಾಂಗಲ್ ಅನ್ನು ಕೂಡ ಕೇಳಬಹುದು. ಎರಡು ಚಾರ್ಜಸ್ ನ ಕೊಟ್ಟು ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಪಾಯಿಂಟ್ ಇಂದ ಚಾರ್ಜ್ ನ ಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಬೇಕಾಗುತ್ತೆ ಅಂತ ಕೇಳಬಹುದು. ಜೊತೆಗೆ ಇನ್ನೂ ಒಂದು ಈ ತರ ಪ್ರಾಬ್ಲಮ್ ಏನ್ ಕೇಳ್ತಾರಪ್ಪ ಅಂತಂದ್ರೆ ಮೂರು ಚಾರ್ಜಸ್ ನ ಕೊಟ್ಟು ಈ ಪ್ಲೇಸ್ ನಲ್ಲಿ ಎಷ್ಟು ಚಾರ್ಜ್ ಇದ್ರೆ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಎಟ್ O is 0 ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ ಅವಾಗ ಕೂಡ ನೀವು ಈ ಫಾರ್ಮುಲಾಸ್ನ ಯೂಸ್ ಮಾಡಿ ಮಾಡಿ